All right, here we go for 12.3 part 2. So we're still talking about concentration of solutions. This one is a little bit shorter than yesterday's. We're going to do fewer practice problems, partly because we don't have to talk about the dilutions part. So with 12.3 part 2, we're going to first review. We're going to review molarity. That's what we talked about in yesterday's lesson, or in the first part of this lesson. Molarity, remember, is the number of moles per liter. So we need to convert to moles. So we have 3 problems here. So the first one is dissolving 5 grams in water to make 1 liter solution. And we want to find what is the molarity. Okay. So we first need to convert our grams to moles. So 5 grams of sugar, C12H22O11. So 12 times 12 plus, oh goodness, okay. Plus 22 for H plus 11 times 16 for O. You should get 342 grams in 1 mole. So you do 5 out of 342. So we have 0.015 moles. All right, and we dissolve that in enough water to make 1 liter of solution. So we take our moles and 1 liter. So the molarity of this solution should be 0.015 molar. Okay, that was pretty easy. The next 2 are dilutions, right? This is diluting. So we're finding what volume of a 0.040 molar solution would be made if we dilute 50 milliliters of a 2 molar solution. So remember, this equation is M1V1 is equal to M2V2. And we can solve for our volume in milliliters. That's fine. You don't have to convert to liters for this. It works out better, I think, if you... I don't think you have to convert to liters for this. So, sorry, looking for the back here. I'm going to go ahead and convert it to liters. So then you would just be solving for your new volume in liters. So I have a 2 molar stock solution. So stock solution just means what I have in my lab, like what's available to me. Okay, what's already prepared. Okay, so the volume, I'm going to convert it to liters. So then I'm solving for the volume. So I have 2 times 0.05, and I divide that by 0.04. So my new volume is 2.5 liters. Okay, if you had solved this, if you had left this as 50, right? So you do 2 times 50 and divide by 0.04. And you get 2,500 milliliters, which is the same thing. So you can leave that. You can leave your 50 milliliters instead of converting to liters. It's fine. You're just solving for it in milliliters. Just make sure you solve for it in milliliters. Okay, one more practice problem. Diluting 50 milliliters of a stock solution with 950 milliliters of water produces a 0.09 molar solution. So what was the original molarity? Okay, and what's the molarity of the stock solution? Sorry, I'm trying to find the answer. I think I may have taken these from somewhere else, not your book. Okay. So if we have diluted, what you want to do with this is you want to use this volume and this volume as like V1 and V2, but that's not quite right. Because we've taken 50 milliliters and we've added 950 milliliters to it. So our new volume, so this is V1, okay, but V2 is 1,000 milliliters, okay, because it's the 950 plus the initial 50. Okay, so I don't know my original molarity, so M1 is what I'm looking for. Okay, and I have 50 milliliters of M1, whatever that is. Okay, I create a solution with a molarity of 0.09 molar, and that is 1,000 milliliters of that solution. Okay, because I started with 50 milliliters and I diluted it with 950 milliliters of water. Okay, so my new volume is 1,000 milliliters. So 0.09 times 1,000, and I divide that by 50. So my molarity is 1.8 molar of the aluminum sulfate. Okay. All right, so let's move on to molality. Molality is just a different way of describing or expressing the concentration. Okay, so in molality, we're expressing the concentration instead of moles per liter. We're doing moles of solute per kilogram of solvent. Okay, so molarity was moles of solute per liter of solution. Molality is moles of your solute per kilogram of the solvent. Okay. So we have table sugar, 17.1 grams of it. We dissolved that in 125 grams of water, and we want to find the molal concentration. That one's really hard to say. Concentration of the solution. Okay, so we are doing moles per kilogram. Okay, and the way that we do molality so molarity was that big old capital M, and now it's a like cursive E lowercase m. Okay, if you are not real good at a cursive M, that's fine. Okay, just write, so in your book it's an italicized lowercase m. Just write a lowercase m, we'll go with it, it's fine. Okay. So our first thing we need to do is, again, convert our grams of our solute to moles. So I'm going to start with 17.1 grams of sucrose, and we just up above determined that that has a molar mass of 342 grams per mole. So I do my 17.1 divided by 342, and this is 0.05 moles. All right, so I can take that, and I have 125 grams of water, but I need kilograms. Do we remember how to go from grams to kilograms? It's just like milliliters to liters. We're going to move the decimal 1, 2, 3 to the left. So I have 0.125 kilograms of water. So 0.5, or 0.05, sorry, over 0.125, 0.4 molal solution. Okay. Let's try one more together, and then I'll let you try one on your own. So we have 13 grams of sodium chloride and 500 grams of water. So 13 grams of the NaCl, 23 and 35 was 58 grams in 1 mole. 13 over 58, 0.224 moles. Dividing 0.224 by 500 grams, or 0.5 kilograms, 0.224 over 0.5, 0.448 molal. Okay. All right, so do the next one on the back of the page. There's only 2 left. Go ahead and try both of them. Pause the video, try both of them, and then come back and check yourself. All right, so this one is working a little bit differently. It gives us the molality, and it gives us the grams of our solvent, sorry. And we got to figure out how much iodine. Okay, so to figure out how much iodine, it doesn't specify, but we're going to find this in grams. Okay, so we want to find the mass of the iodine. Okay, and remember, iodine is diatomic. So we need to take that into account. So instead of, all right, so we first have to find the number of moles of iodine, right? So my moles of iodine over the kilograms of solution, kilograms of solvent, sorry, wow. 0.100 kilograms is equal to 0.480 molal. So 0.480 multiplied by the 0.1. So my moles is 0.048. Okay. So to find the mass, I need to know the molar mass of iodine. So iodine has a mass of 127, but I have 2 of them, so I have a mass of 254. Okay, so I have 1 mole of iodine has a mass of 254 grams. So I'm going to multiply that by the 0.048. So I will only need 12.2 grams of iodine. All right, so then the next one is the same. So if you struggled on the first one, go ahead and pause again. And if you haven't tried the second one, or if you need to retry the second one, because the second one is the same. We're going to find how many grams of NaCl are needed to prepare a 1 mole of solution using 250 grams of solvent, right? So I need to first find my moles of the NaCl over 0.250 kilograms of whatever solvent, and that will equal 1 mole. I don't really even have to do math on this one, because what divided by 0.25 is 1. Right. So I have 0.250 moles of sodium chloride, and I need to find that as a mass. We've done sodium chloride a couple of times. It is 58 grams in 1 mole. So we do 58 times 0.25, 14.5 grams of NaCl. I was not on the screen for any of that. So sorry. Okay. So that is your final answer. Okay. So we first had to find the moles of NaCl and 0.25 kilograms of whatever solvent we used. That gives us a 1 mole solution. So 1 times 0.25 is going to be 0.25 moles of sodium chloride or table salt. And then we converted using molar mass to figure out what's the mass of that I would need. Okay, that is the end of this lesson. You have practice problems to work, but it's just 1 page. There's 4 questions. They should be very straightforward. And then you have a homework. Okay, so that is that.